Okay, so welcome back. We said formation of ionic or electrovalent bond, and we said that compounds are formed by combining ions. They are formed by decombining ions in the inverse proportion of their charges. So what we mean by that is, for example, if sodium, so we have examples. If sodium was to react with chlorine, what will happen? Sodium, the charge of sodium is +1, so let's say the charge is 1, that is +1, and that of what? Chlorine is also 1, -1. So for you to get a compound, you combine in inverse proportion, and that will now lead us to what? Sodium is 1 and chlorine is 1. You may not appreciate this, but let's look at another example. Let's say you are combining sodium and sulfur, 2-. What happened? The charge of sodium here is what? 1, and that of sulfur is what? 2. So 1 and 2, that is the proportion. 1:2 is the proportion of their what? Of their charges. So for a compound to be formed, you combine in inverse proportion. So sodium, remember the metals come first. So sodium now becomes what? 2 sodium, and what? Sulfur is what? 1. It takes up 1, so sulfur is 1. So that is what we mean by inverse proportion of their charges. Let's look at last example. Let's say you are combining aluminium 3+ and sulfur 2-. Aluminium, the charge on aluminium is what? 3+, so 3, and that of sulfur is what? 2-, so 2 here. I see. So it will combine in inverse proportion, and this will give us what? Al2, because it's the metal comes first, S3. I see. So that will be compound formed. That will be your compound formed. Then let's look at one last example. This is very important because a lot of students might miss this. Let's say you want to form a compound between calcium 2+ and once again sulfur 2-. Yes, what is their charges? 2 and what? 2. So what is the ratio here? The ratio here is 1:1, like 2:2 is same thing as what? 1:1. So you will not come and say this is what? Ca2S2. No. The ratio is still 1:1. What do I mean? If you divide both sides by 2, you get what? 1. But if you check the other ones, this is the simplest ratio you can get. If you divide both sides, you'll not be having half. No, we need whole numbers. If you divide both sides by 2, yeah, you will be having a decimal. No, we need whole numbers. So that is the idea. I'll still explain it in other ways. So basically what happens here is that your compound that will be formed is what? This is not the compound that will be formed. Cancel. This is wrong, but let me use red. So this is wrong. So basically what will be formed is what? CAS. No, this is not the marker I want to use. Okay, so as I was saying, what you finally get is what? It's not this is wrong. But what you get is calcium sulfide. So another way to explain this, now let's look at your sodium. Your sodium, for that first example, sodium and chlorine. Your sodium has 11 protons and 11 electrons, and the electronic configuration is what? Or the shell configuration 281. So when you want to form ions, it is easier to lose this one electron and get the outermost shell filled. So all atoms are trying to get the outermost shell filled, and that is what causes the loss and gaining of electrons. So what happens? Sodium will lose this one electron and become what? Sodium positive. Why positive? Because before there were 11 protons which are positively charged, and there were what? 11 electrons which were negatively charged. But what happens? Since it is losing an electron, they will now become what? 11, this 2, 8. They now become 11 protons and what? Which are positively charged, and 10 electrons which are negatively charged. And because of that, they are more positive than negative. So we now have 11 minus 10 is what? 1 more positive than negative. So that's why we just have sodium as plus. Why not 1 plus? Because it is simpler to just write plus. It looks more appealing. Okay, so having said that, so that's how we get our what? Sodium ion. But what happens is that for that sodium ion to be formed, for sodium to lose an electron, someone must be gaining that electron. Yes, someone must gain it. Like we said, nothing just happens. So any electron that is lost, someone is gaining it. And that is where chlorine comes in. Chlorine is 17, which is 2, 8, 7. So instead of chlorine to lose 7 electrons, it's easier to just gain 1 and make it what? 2, 8, 8. That way the outermost shell is what? Filled. And that is where it gains 1 electron, because it's gaining a negative particle. It becomes what? Negatively charged. Still 17. So what happens here? We have 17 protons which are positively charged, and here we have what? 17 electrons which are negatively charged. But on the formation of the charged particle, that is the chloride ion, we have 17 protons, and how many electrons? We have gained 1 more electron, so we have what? 18 electrons. So we have 1 more negative particle than there are positive particles, and that leads us to what? Negative. So that is how they are formed. So because it loses 1 electron, we need 1 chlorine to gain that electron. But in the case of sulfide, let's say if it's sulfur is 16, 2 minus, and sulfur is 16, so it will now become, that is 2, 8, 6. So it's easier to just gain 2 electrons and become negatively charged. So it gains 2 negative particles, are you seeing it, and becomes 2, 8, 8. I don't need to go through the other details. I believe by now you got the concept. So sulfur is 2 negative. So for us to get, so remember that sodium is just losing 1 electron, but sulfur has to gain 2. So having, if you want to combine sodium and sulfur, this one just lost 1 electron, this one needs 2. So if after losing that 1 electron, you have 2, 8, 7 here, it's not still balanced for sulfur. That is why we require 2 positive sodium ion to combine with 1 sulfur. So by the time this one loses 1 electron, this one loses 1 electron, your sulfur will see 2 electrons to gain, and that will now give us the compound sodium 2. So 2 sodium against what? 1 sulfur. So that is what all this chemical bonding that I've been showing you, that is what this was about. Do you understand? So this is the easy route, like this is the actual first principle explanation of this concept. So I hope you understood this. So let's look at a table of how these compounds are formed. And because one thing we said when we were looking at, I don't know, okay, we have not looked at the periodic table. Their properties we call periodically. So properties on a group are all the same. Not necessarily all the same, but there's a pattern to it. Let me use that word instead. So let's just look at this table of your first 20 elements. Please, you have to pardon my table. Let's say this is your group 1, 2, 3, 4, 5, 6, 7, and 8 or 0. So we have this. So we say all group 1 elements, the ions will be what? The ions we have to lose 1 electron, and once you are losing 1 electron, they are becoming positively charged. So 1 positive. So that's why you see here your lithium. Starting from lithium, we ignore the hydrogen and helium. So lithium is positively charged. Under lithium, we have your sodium. Your sodium is positively charged, then your potassium is positive. Then same thing to your group 2 elements. You have your beryllium, group 2. So the outermost electrons are what? 2. So that means they will lose 2 electrons to form a charge. That's why they are all 2 plus. Magnesium is also 2 plus, and calcium is 2 plus. Group 3, your boron is 3 plus, your aluminium is 3 plus. These are things if you just know. Jam will never give you this one, so load them for yourself. I've worked with a couple of international students, and over there they give them your periodic table work. Your jam will not give you a periodic table, so you should have all these in the back of your head or your mind. So we have 3 minus, we have phosphorus, 3 minus. So you might be asking what happened to group 4 elements. You will see them when we talk about the covalent bond. So the form of covalent bonds, because they are neither there nor here. So then the next we have your oxygen 2 minus and sulfur 2 minus. So oxides and sulfides. That is what this one is from. Then your fluorine, fluoride, chlorine, chloride, bromine, bromide, and if you go down iodine, you should form your iodide, and so on. So these ones, they are noble gases, so they don't react because they already have their outermost shell filled. So these are this is the trend on the periodic table. So if this group 1 wants to form with group 7, what will you have? You have, let's look at it. So work out this table for ourselves. So see group 1, group 2, and group 3 elements against your group 5, which are against the negative sets of guys. So group 5, group 6, and group 7. So what do we have here? If this first we have the lithium, sodium, and what? Potassium. So this is your own assignment to make sure you complete this table. Then let's take example of group 5. We'll do for the first set, which is 3 minus and P 3 minus. While group 6 we have oxygen 2 minus and sulfur 2 minus. While this one we have fluorine, chlorine is just minus, and chlorine and bromine. So let's do this first one. Lithium, when lithium reacts with group 5 elements, or when group 1 element reacts with group 5, what do you get? You see they react in their inverse proportion. So let's come here. So we have lithium 1, while nitrogen is what? 3 minus. So if they react, we have what? Lithium 3, nitrogen. Excellent. So we say lithium. Your compound form will be lithium 3, nitrogen. Let's see for the other one, sodium 3, phosphorus. Excellent. Then we can have potassium 3, nitrogen, and phosphorus 2. So you can just complete it. Make sure you complete this table. Then similar thing here, we have lithium 2, then oxygen. This is your lithium oxide. Or we have sodium 2, then sulfur. So this is sodium sulfide. Then for this last one, we have sodium fluoride. So 1:1. We have potassium chloride, and so on. So make sure you complete this table for your own good. It will help you still better. So that is what it's for your electrochemical bond. So your electrovalent bond. And this electrovalent bond, they have some properties. The compounds form have some what characteristics. And what are those characteristics? They have high boiling and melting points. So characteristics of ionic compounds. So I will not explain the other ones this deep because this is the foundation of when we start talking about the other ones. So characteristics of ionic compounds. Number one, we see they have high melting and boiling points. Then number two, they do not conduct electricity in solid states. So they do not conduct electricity in solid states. But by the time you look at metallic bond, I hope I wrote metallic bond. Yes. So by the time you look at metallic bond, you see that metallic bonds they conduct electricity in solid state. Right? This one they do not conduct electricity in solid states, but they conduct electricity in molten or when they're in solution. So they conduct electricity in molten states. Or when in solution. So when you put it in water, it will form what we call ions and conduct electricity. So what conducts the electricity? The ions. So through their ions. The another thing you want to know is that they are insoluble in organic. When we say organic, all these fats, oil, kerosene, they are insoluble in organic solvents. And lastly, we want to say they mostly exist in solid states. So this is the strongest form of bond you will see. Alright, so having said that, let's move with the speed of light and touch other classes of intramolecular bonds.